Hi, this lesson we will continue with hypothesis testing, and we will focus on probability of type 1 and type 2 errors. Okay, in my previous lessons, I discussed the definitions of type 1 and type 2 errors. So which are type 1 error, H now is rejected when H now is true, and the type 2 errors, H now is not rejected when H now is false. Okay, in these lessons, we are calculating the probability of type 1 and type 2 errors. So in order for us to do so, the critical value is important. So that is the value that separates the rejection regions from the acceptance region. For example, let's say we are carrying out a test where the mean 3.2 and the H1 is that the mean less than 3.2. All right. So in the sentence of the questions, it has to give you the critical value, or what we call the critical region in terms of the X bar. So reject H now if the X bar is less than or equals to probably, let's say, 1.5. Okay, so with this given, means if the calculations found is less than 1.5, then we will reject the H now, right? So the 1.5 is the critical value, and this is the rejection region. Rejection region. And here will be the acceptance region. Okay, now let's have a look of an exam questions. So this is a May, June 2003. Last time it used to be called the paper 7, right? Question 5. Over a long period of time, it is found that the time spent at cash withdrawal points follows a normal distribution with mean 2.1 minutes and standard deviations 0.9 minutes. A new system is tried out to speed up the procedure. So to speed up the procedure. The null hypothesis is that the mean time spent is the same under the new system as previously. Okay, it is decided to reject the null hypothesis and accept that the new system is quicker if the mean withdrawal time from a random sample of 20 cash withdrawals is less than 1.7 minutes. Okay, assume that for the new system, the standard deviation is still 0.9 minutes and the time spent still follows a normal distribution. Part 1, calculate the probability of a type 1 error. So we are going to calculate the probability of type 1 error, but first, let us try to understand the questions. Like, first thing, we are talking about the time spent at cash withdrawal point. It follows a normal distribution, right? Okay. Time spent follows a normal distribution where the mean is 2.1 and the standard deviation given to be 0.9 squared, right? This is meant for the variance. Okay, so if we were to carry out a hypothesis test, then we must have the H now, where the mean is supposed to be 2.1, right? As given by the questions. the null hypothesis is that the mean time span is the same under the new system as previously. But we are expecting the new system to speed up the procedure. If that is the case, H1 should be less than 2.1 minutes, right? Because speed up the procedure. So if we were to carry out the testing, we have to look for the sample mean distribution. So it's supposed to be X bar distribution, where it's also going to be normal with the same mean 2.1, but the variance must be divided by the sample size, a random sample of 20 cash withdrawals. So divided by 20 here. All right. So the very important sentence in order to help you carry out the calculations of type 1 error is this. Maybe I put it in red color here, this sentence. So that is the critical region. In terms of X bar. Okay, so it is decided to reject the null hypothesis and accept that the new system is quicker. Means we reject H null and then automatically we accepted H1, that the mean is quicker, less than 2.1 minutes. If the mean withdrawal time from a random sample of 20 cash withdrawals is less than 1.7 minutes. So 1.7 minutes is the critical value. And the whole sentence will give you the critical region or the rejection region. So I will write this down. Means we are going to reject H null if the X bar, the mean withdrawal time is less than 1.7 minutes. Okay. Now we will be able to calculate the probability of type 1 error. So in the definitions of probability of type 1 error, H null is rejected when H null is true. So that is why we are making a mistake. So that is an error, and that is the type 1 error. So what is the probability of that? Now, H null is rejected. When do we reject the H null? When H null, that means this one, the X bar is less than 1.7 minutes, right? X bar less than 1.7 minutes. That is where we rejected H null. But we realize that H null is true. What does it mean? It means that the mean remains at 2.1 minutes. So in order for you to calculate the type 1 error probability, we are going to find the probability of X bar less than 1.7 minutes and take the same normal distributions for the sample mean here. Okay. So let's calculate the probability. Standardize. Okay, divided by standard deviations. So calculate out the value of this, and you should be getting negative 1.988. Okay, just a quick sketch of the bell-shaped curve. And negative 1.988 is somewhere here. And refer to the table to get to the probability. All right. So let me scroll down to look for the table that I get it here. 1.9, 8, and 8. So the value this and this. So 0.9761 and 5. So total is 0.9766. And we do know that the probability is coming from the smaller region. So we are going to take 1 minus 0.9766. And hence, we found the probability of type 1 error is 0.0234. All right. Okay, now we move on to look at the type 2 error probability. So part 2. Right. If the mean withdrawal time under the new system is actually 1.5 minutes, calculate the probability of a type 2 error. Okay, now we are going to find probability of type 2 error, and which means H now is not rejected when H now is false. It's a false value, but you do not reject it. That's why we are making a mistake, and that is the type 2 error. So we are going to find out the probability of this happen. So again, when do we not rejecting H now? When, refer back to the same sentence, when the X bar is more than or equals to 1.7 minutes, right? That is where we do not reject H now. But we realize that H now is false. So we are not going to use these X bar distributions anymore. We are supposed to take the X bar distribution with the mean given by the questions here, right? Actually, the mean should be 1.5 instead of 2.1. But then we are assuming that the standard deviation remains at 0.9. So 0.9 squared over 20 is still the same. And hence, when we are finding the probability of X bar greater and equals to 1.7 with this new mean, we are finding the type 2 error probability. Okay, so let's calculate. Standardize it. And find out this z-score value to be 0.994. So let's have a quick sketch. 0.994 somewhere here. And greater than, so this is the region. So same thing, we refer to the table to get to the probability. 0.99. So this is the probability, and 4. Here is a 4. So this 98389. So it's 8389 and 10. So 1 also, which means 0.8399. And we know this is also the smaller region. That means we are going to take 1 minus 0.8399. And hence the probability of type 2 error is 0.1601. And we have found the type 2 error probability. Okay, so just a quick summary here. When we are calculating the probability of type 1 errors or type 2 error, the most important thing is must have the critical regions in terms of X bar here. All right. So the question has to give you this sentence. You have to be able to determine. Right. This is the important point for you to calculate the probability of type 1 and type 2 error. And for the type 2 error probability calculations, the questions have to give you the actual value, the actual mean, or the supposed to be the correct value, or the true mean, right? Because why? Because as we are calculating type 2 error, means the H now is false. If the H now is false, means the given value in the beginning cannot be used anymore. So it has to give you the new mean or the actual mean, right? So that is where it helps you to continue your calculations to find the type 2 error probability here. All right. So that's all for these lessons. Do subscribe to the channel and like these lessons here. And that's all. Bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.